Okay, good afternoon everyone. So, my name is Stephen Mccann. I'm indeed with Huawei. Strictly speaking, I'm actually a consultant with Huawei. And I'm just setting myself up. I'm also the 802.11 Vice Chair. And some of you may have heard of 802.11. Okay, let's get started then. So, okay, ready? All right, I just want to actually start by sort of leading on from Alain's presentation. So, I will jump to the beginning of my presentation in a minute, but what I'm just going to show you very quickly is that you probably don't know that within 802.11 we actually have this funny little group here called AIML TIG, Artificial Intelligence Machine Language Topic Interest Group. And just to sort of let you know that what we do in .11 is before we start our projects, BE, BN, BI, all those lovely letters that you guys know, is we quite often start off with study groups or topic groups, and one that we currently have at the moment is all about AI. All right, and basically what we're trying to do there is look at how can AI or machine learning actually assist Wi-Fi. Can we actually build anything into the .11 standard? But before you get too excited, we are looking at sort of 5 to 7 years' time. Okay, so nothing at the moment, but just to let you know, if you're interested in that sort of area, we are considering it at the moment. Anyway, I'll come back to that later on. So, what is this all? Okay. I hope you took that all in. Okay, fine. So, as I said, I'm the Vice Chair at .11. I've been in .11 since about 2001. I actually started in Hyperland 2 in Etsy, if any of you know about Hyperland 2, back in about 1997, but we know the history of Hyperland 2, so end of that. Alright, so a lot of this is going to be information you already know, and I think because I've only got 20 minutes, based on your reaction, if it's boring, I'm going to move on. Okay? So, very quickly, I'm sure you all know this, but really what I want to talk about today is what is Wi-Fi 7 all about? What are the main changes? And then I want to get on to Wi-Fi 8, which we are now developing, which you know as BN. Okay? So, BE, BN, and I may even get into Wi-Fi 9, depending how good you are, and as long as you don't ask me any really nasty questions. Do I need to go through this? No? Good, cool. Alright, now the reason for this one is I want to make this clear distinction between .11 and the Wi-Fi Alliance. Myself, I am a member of .11. As I said, I've been in .11 for about 23, 24 years. In .11, we represent ourselves as individual engineers. In .11, I just happen to be sponsored by Huawei, but I've been in .11 with Siemens, with BlackBerry, even by myself for a while. It doesn't matter which company you belong to, because in .11, you actually act as an engineer by yourself. Wi-Fi Alliance is a promotion organisation for Wi-Fi technology, and within the Wi-Fi Alliance, I represent Huawei. In the Wi-Fi Alliance, we have developed Wi-Fi 6, Wi-Fi 6E, Wi-Fi 7, Wi-Fi 8, etc. All those Wi-Fi terms are marketing numbers created by the Wi-Fi Alliance. In .11, as I've just shown you on that previous slide, we have all this complexity of all these crazy letters, and you just have to remember that BE is Wi-Fi 7. Okay, and then BN will be Wi-Fi 8, etc. And I'll come back to that later on. Okay, so what were the goals of BE in the term? Remember, this is all about standards. I'm not a developer, okay? So please don't ask me about Intel chipsets or anything in TIA or anything like that. So what we wanted to do was review some of the concepts introduced in 11AX, Wi-Fi 6, loads and loads of errors, loads of issues to sort out. Some people basically said that Wi-Fi 7 was really Wi-Fi 6 plus, in other words, sorting out all the errors. Hopefully we've gone beyond that a little bit. Some of the main things we needed to address were the OFDMA and the resource units, because that's like a new concept within Wi-Fi 6. We wanted to look at the target wake-up time, the TWT, and also some aspects of preamble puncturing. Wi-Fi 7, we decided we wanted a maximum throughput of at least 30 gigabits per second, at least in one mode of operation. And then, as with all the Wi-Fi technologies, we wanted to make sure it operated in the 2.4 and the 5 band, backward compatibility with legacy devices, and we wanted to enhance the 6 gigahertz operation, especially in the area of security. And as I was asked at lunchtime, someone said to me, "Hey, what's going on about WPA3, 6 gigahertz and security?" All I can say at the moment is it's a mess, right? And I really don't have time today to go into WPA3, but if you get hold of my email address and you want some more information, please send me an email afterwards, and I'll try and give you some more background material about that. And then the last thing on the slide is just talking about the usual things about trying to improve worst case delays and jitter and things like that. The key sort of enhancements for Wi-Fi 7, so again we're talking about BE at the moment, are to basically double the channel bandwidth from 160 to 320 megahertz. We've also increased the QAM 496, but as you know, if you start doing this sort of thing, then you have heat issues and you have melting chips and other nasty things like that. So I do believe there are some implementations out there of using 4096 QAM, but my understanding is it's not always reliable. But as I said, I'm not a developer. I'm allegedly an inventor. I don't know. And then the other thing is that obviously the data rate's been increased up to 23 gigahertz. I think it actually goes slightly higher than that. And then we have this thing also called multiple resource units as well. Yeah, that's right, okay. So I keep getting confused because I know that we've just introduced 640 megahertz bandwidth, but I think that's going to be for Wi-Fi 8. Okay, lots of lovely things here. I'm not going to go through all this again. I'm limited to time today. And I'm sure that most of you understand quite a bit of those things, probably more than I do. So one of the things that we wanted to do was moving away from OFDM in Wi-Fi 5 to OFDMA, the access variant. The main benefit of this is that by using OFDMA, obviously multiple users can transmit at any particular given time, as long as they have access to the media. 11AX Wi-Fi 6 was the first Wi-Fi technology to do this, but it had some limitations, and we wanted to extend that sort of mechanism in Wi-Fi 7 11BE to basically make it more efficient. This is just a quick recap of what the resource unit allocations look like for various bandwidths. And there's also further charts now showing 160 megahertz and 320 megahertz bandwidths, but those diagrams just get too complicated. Yeah, I think I've been through that already. Okay, another aspect is talking about triggered uplink transmissions, and triggered really just means unsolicited. So this basically means that the client, the station, can actually decide to sort of initiate its own uplink transmission prior to Wi-Fi 6. Basically, the access point had limited or no control over the uplink transmission, but Wi-Fi 6 makes this a little bit more symmetrical. There are some use cases where this can make things a little bit more efficient, especially when you have a much more sort of balanced uplink, downlink sort of data throughput situation. Yeah, I think that's all fairly obvious. Okay, cool. The reason I'm rushing through this is because I'm trying to get to this thing here, multi-link operation in Wi-Fi 7. So one thing that we have decided to do is to aggregate the Wi-Fi bands and aggregate the links. So currently we obviously know that a link is mapped to a specific channel in a specific band, i.e. channel 6 and the 2.4 band. And these basically operate independently. So in Wi-Fi 6, you will typically have an access point, a router that will have multiple radios, and you're serving a 2.4 channel and a 5 gig channel. You may have a 6 gig channel as well. However, those channels are acting independently of each other. You may have separate radios, you may multiplex one radio between the different bands, but from a sort of logic control point of view, those channels, are treated separately. Wi-Fi 7 introduces a mechanism whereby we can have multiple links on different bands operating simultaneously, and the control is basically changed. So Wi-Fi 7 introduces this multi-link device, and as it says on the screen, it's a logical entity, and it has these things called affiliated stations. So on the AP, we now have affiliated APs, and on the station, we've got affiliated stays. If you look in the standard for Wi-Fi 7, which is BE, you'll see that we use this horrible term, non-AP stay, non-AP stay. On the AP side, each of these affiliated access points are conventional access points, although to some extent consider them as radioheads. Okay? The encryption and the way that we do fragmentation and some of the other control mechanisms are actually moved out of these affiliated APs and moved up into the AP MLD itself. So that's the access point multi-link device. Another way of thinking about this is consider that a lot of the sort of medium access control software is moved out of these individual APs and is moved up into here. Okay, so these things are the physical layer plus a little bit of software on top. Okay, but the control and the management of the whole access point is now done at the upper level. Okay. The same thing happens on the client, on the non-AP MLD, although typically the clients are probably going to be simpler. Okay? So what we're looking at here is a client device probably will have 2 links in the first products. For the AP, we're possibly talking of sort of 16 links, 64 links, something like that. But the point is, they all operate independently of each other. Okay, so I'm not going to go through this. What I want to say here is that from a standards point of view, there's been some radical changes to the multi-link architecture, the ML architecture. We've had to shift a lot of things around, especially when it comes to encryption and security, and the way that we do fragmentation and the assignment of sequence numbers and packet numbers, block hacks, all those sort of things that we've had to basically change. And yet, even though we've done all this, we still have to keep that fundamental sort of property of Wi-Fi that everything has to work with previous generations. Okay, so even though the architecture has changed for Wi-Fi 7, we still have to make sure this will work with Wi-Fi 4, 11AC, 11AX, all these previous generation devices. Okay, so what are the benefits? So the main benefit is the throughput boost. As I said earlier, we're now aggregating multiple links for data transmission, so now we can simultaneously transmit in the 2.4 and the 6 and things like that. The other nice thing is that if you do have some serious issues with, say, your 2.4 band for some reason, you can actually duplicate frames or duplicate packets on the different bands, basically looking for a band where the data gets through. Because of that sort of hierarchical architecture I showed you on the previous slide, the decision-making about which of these links can be used is now in the AP-MLD level. It's not down at the individual AP. Okay? So if you think about Wi-Fi 6, I'll come to this side. If you try and do this in Wi-Fi 6, what you'd be doing, you should be sending data to each individual Wi-Fi 6 access point. They'll be trying to transmit, and then they'll come back after a few hundred milliseconds and say, my data transmission failed, and then you'd have to rebuffer it and then move it across to another AP and then retransmit. And this would have to be managed by probably an AP controller at the back here.
Just to clarify,
yeah,
when
sure.
you're talking about APs, you're talking about radios, right? In a single AP.
No, I'm talking about these. Yeah, you're right. Sorry, these are affiliated APs. Okay.
What are affiliated APs?
Yeah,
Affiliate-
you're talking about radios. In an AP.
We're used to APs with 3 radios in it.
Yeah, but the radio was APs.
Yeah.
I'll just go back here. It's okay. It's all right. So, what we're doing here is we have these are affiliated APs, and these are basically they are APs with a single radio. Okay, but what we've done is that some of the software in each of these single radio APs has been moved up to a higher level. Okay, so a good example is security. So the encryption and the key generation is being taken out of the AP and it's being moved up into this higher layer, right? Other aspects of the management have also been moved out as well. So, for example, fragmentation has been moved up, right?
But it's one single device, right? The AP-MLD is one single device.
This is, at the moment, just consider this as one single device.
An AP, which has multiple radios.
Consider this as a single AP, okay, within which you've got, I suppose the best way to describe it is these are the radios, okay, but the radios in Wi-Fi 7, these are basically what you would consider to be APs in Wi-Fi 6, okay. No. So from that, okay, so yeah, sure, okay, right. Okay, so from that, that's fine. So from so from a product point of view, an APMLD is a single box. Okay, it's a single box. Within this box, you have a Wi-Fi core for each of these AP1, AP, AP3. Okay, and connected to the Wi-Fi core, you have a single radio for a band. So in this case, you've got 2.4, 5, and 6. Okay, so consider these to be simple single radio APs. Okay, all right. Now these simple single radio APs may still be 2x2 or 4x4 MIMO. Let's not worry about that. But in terms of the bands that they can transmit and receive on, it's 1. Okay, so link 1, link 2, link 3 are single channel, single band radios. Okay, we okay with all that? Okay. Yeah, right, good. Well, I'm a radio engineer, so that's all cool. All right, so going back to this one, as I said before, the advantage of doing this means that if we go back to this diagram here, okay, it means now we have an entity with 3 radios inside it. Okay, so therefore you can transmit on the 3 radios simultaneously. Great. Now you might think to yourself, well, okay, fine, we can do that anyway. The main difference with this model is that the things like encryption, fragmentation, and management of the whole system is now done at the upper level. We're not purely doing encryption down at each individual radio node, okay? We're doing this at a higher level. And that means that in this situation, where say your 5 gigahertz link is not working very well, you can actually manage the data throughput, or you can redirect the data onto another of the radios, in this case 6 gigahertz, within this sort of upper APMLD. You don't need to wait for reports to come back from this individual. Well, you'll need to wait for the failure, obviously, but what I mean is you don't need to rebuffer everything. Okay? It's all done basically in smart software at a higher layer. Okay? Does that make sense? A bit more sense? Okay. Now you're probably saying to yourself, yeah, sure, this is going to happen, you know, a bunch of idiots, whatever. But again, this is sort of, this is in the standards, so we're talking of, a few years ahead. A couple of other benefits of doing this means that you can now, again, split off different bands for different types of data. I know you can do this at the moment, I agree. But for example, here on the real-time traffic on a couple of bands and then non-real-time traffic on another band. But again, because the management is centralized, it's a little bit easier to manage. Now, another one I'm going to show you, I'm just going to jump forward because I only just added this, is one thing you can do is you can do basically a new form of mobility. That's the best way to describe it. So this would be an APMLD in a fairly large area. So example, the hotel, a warehouse, hospital, school, that sort of thing. The APMLD has got 4 affiliated APs, or what we call these radio heads. Okay, 2 in the 2.4 band, 2 in the 5 gig band. We have a single client here with, again, 2 affiliated stations. These these radio heads are connected to a single. So this is like a laptop with 2 radios, and this associates. So we have association on the 2.4 band and on the 5 gig band. And then the thing that can happen is that if this client device decides to move, we can have one of those radio heads can go from the 5 gig band here to the 5 gig band here by physically moving. And you may think, yeah, okay, fine, well, we can do that anyway. But in this situation, because we are maintaining the 2.4 link here, we maintain the association. So we do not drop the association, we do not need new keys, we don't need a new IP address. It's still associated even though one of the radios has moved. Okay? Then, what we can do is we can move the other radio across. Okay? So we can drop it from the 2.4 over to this 2.4. This radio has maintained the association. Okay? So what we've done here is we've done a movement within the same coverage of this APMLD, and we haven't actually changed the association or any security or anything. Okay? So in other words, this is like a non-roaming situation for moving these devices around. And this, we think, is probably going to be 70-80% more efficient for roaming scenarios than currently what we have in Wi-Fi 7. Okay. So I'm just jumping around a little bit.
Isn't this something a bit the same like the channel blankets from, I believe, Iraqi, was it?
Iraqi.
I reckon.
Sorry?
The rule single channel.
So Iraqi, yeah.
Channel blankets. Not single channel.
Variable kickback.
No, it's not. It's a little bit more different from that. Okay, now this is some of the. This is almost like the truth, in a way, of what we're trying to do. So this is going towards thinking about products. So what I have spoken about was an ideal situation for multi-link operation. In practice, what we're probably going to have is a whole set of strange variations on multi-link operation based on the number of radios inside, based on the number of radios on a specific chip. How many bands are supported, and then how many radios do you actually want in a product? Okay. So again, I'm not going to go through all this in detail, but as you can see, we have a concept called multi-link single radio, which is where the radio will multiplex between, say, 2.4 and 5 gigahertz on a sort of 200 millisecond basis. So it's going to constantly be switching between them. We have enhanced multi-link single radio, where we have a single radio, but the single radio can listen on 2 bands simultaneously, so it can listen both on 2.4 and 5 gigahertz band at the same time, but only transmit on one. We have another scenario where you can transmit and receive on a multi-link radio, but the multi-link radios can't do it simultaneously, so you might have a 2.4 band radio and a 5 gig radio as separate front ends in an access point, but you still have to switch between them. Okay. And then the opposite one is obviously the simultaneous transmit and receive, which is getting quite nice because then you can do clever things. And then the one at the bottom here is the full multi-link operation where you can do transmit, receive on any bands within the multi-link device simultaneously, and you can actually dynamically configure the spatial multiplexing capability. So in other words, on this one, you may have, say, 2 radios in the 5 gig band with some channel separation, one of which might be a 2x2 MIMO, and the other one might be an 8x8 MIMO, and you can dynamically reconfigure them. Okay, that's really going a little bit far into the future for that one. We haven't worked that one out completely. Yeah. Let me just check, make sure I've done all this. So okay, so this is a little bit more detail about Wi-Fi 8, otherwise known as 11BN. We started work on this about 18 months ago. In addition to what I've already spoken about, we're working on multiple access point coordination, and again, a lot of you know that's possible already. We're looking at how we can support low delay applications. We're looking at multi-link architecture. We're also considering how do we cope with this when these affiliated APs are physically separate. This is called co-located. And that's difficult because one of the problems with all these affiliated radio heads or access points is you need very, very tight timing, because remembering you may get a situation where each individual packet goes to a different radio link. So we think we need about 10 nanosecond timing between each of those affiliated APs. That's fine if they're on the same chip, but as soon as we start to separate them, we have some serious issues. So one of the thoughts there is that we could have separate radio heads, but we'll need optical fibre connections between them. And I mean optical fibre straight to the radio head. Okay. We're looking at this thing called non-primary channel access. So we could have a 5 gigahertz channel with a 2.4 secondary channel. Okay. So the 5 gigahertz channel might act as a pilot and give you information about the other links. Dynamic resource units, that's just building on the resource unit methodology that we already have in Wi-Fi 7. And then the final thing is unequal modulation, where we just basically dynamically play with the modulation schemes on each of the radio links. Okay, so I think that's probably enough about that. So I think I'm just going to finish by saying that Huawei, because I've not really mentioned Huawei very much, Huawei, we actively participate both in .11 and in the Wi-Fi Alliance. And for Wi-Fi 7 and indeed Wi-Fi 8, we're currently we are the main contributor of documents and submissions into Wi-Fi 7 and Wi-Fi 8, and also we're one of the biggest contributors of patents and IP and things like that. So that's my sort of marketing spiel there. As I said, I'm the vice chair of .11 now, so I have a lot of things to deal with. We also have Osama, and I think some of you may have met Osama before. He was the chair of 11AX. He's sort of now starting to think about early retirement. And we also have a gentleman called Edward Owl, and he's the technical editor of 11BE, which is Wi-Fi 7, so he has a huge job trying to sort out that document. And I think at the moment that document by itself is running at nearly 1,000 sides. So it's considerably bigger than AX, for any of you who have enjoyed reading AX. Yeah, okay. So I'm just going to hand over to Ronald, just to give you a couple of other points about Huawei. Before I do that, two things. First of all, I've given you an awful lot of information. Some of it is probably new, some of it is controversial. Please feel free to send me emails or ask me questions afterwards. If you Google 802.11 Stephen Mccann, you'll find my email address everywhere, okay? Because all the material's in the public domain. And then the other thing is, if you find issues with AX, especially, any of the published standards, BE, if you're able to access the drafts of BE, if you find things that just don't work or what just don't make sense, or you think there's errors, please reach out to us, because we're just engineers. If you can reach out to us, then we have a process of being able to fix bugs, okay? It's quite easy for me to go and fix bugs. It'll take perhaps 6 months or a year to do it, but I'm able to do that. So again, if you've got bugs or issues, let me know, and I'll try and help you out. Okay, so as I said, I'll hand over to Ronald for a second.
No, you can just take
Okay, fine, cool. I mean, all I really want to do by finishing is just say, you know, Huawei has produced several routers which are Wi-Fi 7 capable. I think we're up to 6 or 7 actually at the moment. 8, okay, 8, yeah. So this slide's a bit out of date. And as I've said to you, you know, we are well known within the standards community, and hopefully we produce good stuff. So, you know, please consider our help and support going forward.
On what version of the draft are these devices based?
Yeah, I don't know that one. Ronald, do you know what the base of the version is?
I have 7 products coming out by the end of this month, which we can actually sell already. And yesterday we heard that we've won already a project with it. And they're based on the latest draft that has come out. But they can all be upgraded to the right things. They all are with a Qualcomm chipset.
Okay, so in which case that's going to be 11BE draft 5.0. Yeah, that's the latest one. Okay. Yeah, hi.
I wonder about the multi-link operation. In practice,
Yes.
how much does it drain your battery of your phone?
Probably an awful lot. I share your concern. You've got a lot of multiplexing going on in your phone, and as I said earlier, there's a lot more sort of management going on in that upper layer of the APMLD because it's having to monitor the 2 separate radio heads. So power consumption is a serious issue. Yeah. On that point, what I was going to say is that generally within 802.11 we are looking at power for the whole of Wi-Fi. As you may know, in 3GPP for 5G, 6G generation cellular, they are taking power consumption seriously into account, for climate control, etc. And we're starting to do that within Wi-Fi as well. So we will have an upcoming project which is going to look at power consumption because we've got to get it down. And as you say, moving forward to Wi-Fi 8, we have a power issue that we have to address. Okay, this is a chart of all the current projects in .11, which I started with about half an hour ago. Do you want me to run through it, or is it boring?
You mentioned Wi-Fi 9.
Yeah.
Already on there?
Wi-Fi 9? Where is it?
BI? BF?
No. Is it? Yeah. Where is it? It's probably this one here. Okay. I'll run through them. Have I got 2 minutes to run through them? Okay, fine. All right. So the way this works is these are different groups in .11 as of last week. So here, this is basically wireless next generation or what's next group. It's basically ideas. We get people presenting ideas. If they're any good, then we start looking at things. So at the moment we have artificial intelligence, machine language topic. We have something called ambient power, so very, very low power, energy harvesting, IoT, that sort of thing. That will become 802.11bp, probably in May. This one here is Integrated Millimetric Wave Study Group. These guys are looking at how can you take existing 5-6 gigahertz core Wi-Fi chips and move them up to 60 gigahertz. Okay, so in other words, this is millimetric Wi-Fi using existing lower band technology. Some people have said this may start to become Wi-Fi 9. We haven't really decided yet. 11BI, this is enhanced data privacy. So this is looking at how can we basically add some special numbers and things or sort of manipulate management frames so that we keep people's privacy. I mean, the obvious one is MAC addresses. Let's see if we can spoof MAC addresses, sorry. Stop spoofing MAC addresses. If we can randomize MAC addresses and things like that. BN, this is Wi-Fi 7, ultra high reliability. I'm sure you know about that one already. And as I go across, things are maturing over towards the right-hand side. BH, random and changing MAC addresses. That really was just a few small fixes. Okay, it's nothing to worry about. BF, sensing. So this is actually using Wi-Fi basically as a sensing radar. Bouncing off objects, trying to determine what things are in a room and doing clever things like that. BK, this is positioning using 320 megahertz bandwidths, because positioning at the moment only uses 80 megahertz bandwidths, and obviously if you increase the bandwidths then you can refine the position of objects. So this is like ranging and sounding and things like that. Revamini, forget that one for now, you don't need to know about that. BE, I'm sure you've heard of this one, Wi-Fi 7, extremely high throughput. This is basically, as I said, draft 5.0, that means we've had 5 iterations of the BE draft. It's coming to maturity, it's probably going to be finished by the end of the year. And what I mean by that is that the BE amendment will be published as a complete finished item, probably by about December this year. These things here have basically been finished and published in the last 4 years. Okay, so we have AZ, next generation positioning. This core one was a corrigendum of errors that was being sorted out. BCS, broadcast services, so this is a sort of new broadcast mechanism primarily for access points. BA, wake-up radio, okay, so again this is for a dual band access point, 2.4, 5 gigahertz band. Basically you shut one of the links down and then you can send some very, very low energy wake-up signals to sort of wake things up. BB, light communication, okay, so using lights like this, so downlink can be 100 gigabits per second, and then uplink is on the 5 gig band. That's like for streaming and some specialized use cases like that. AX, which is Wi-Fi 6, see if I can remember what it's called. High efficiency wireless LAN. I should know that. I'm the guy who came up with those words about 10 years ago. 11AY is next generation 60, so in other words 60 gigahertz improvements over and above 11AD, which came out a long, long time ago. Corrigendum 2, that's the second set of bug fixes. 11BD, sorry, that was not AY, it was, what was it? I'm trying to remember what AB, I think, or something, I can't remember anyway, yeah. But these are the corrections to the earlier one anyway. This is next generation vehicle, BD, so this is an enhancement for 11P, which came out in 2012, I know that one, right. So what happens is, the current baseline for .11 is .11 2020. So what we do is, when you have 4 published amendments, you basically take them and you roll them into this. Well, we have loads more than 4, so at the moment we are going through the process of rolling them up, and we should have an 802.11 2024 at the end of the year, in December. And when that happens, all these will sort of disappear and we have a clean sheet and we sort of start again. So we're at the end of a 4 to 5 year cycle where we basically wrap everything up in 802.11. Right, I'll stop there because I've spoken far too long. Good, all right, so you've probably got loads of questions. I don't know what the time's like, but please feel free to talk to me afterwards or send me an email and I'll try and help you out. Okay, thanks.